Okay, good morning class. So today we're looking at probability. Okay, so at this point we have read through all the introduction and the previous definitions and explanations of certain words that is used and synonymous with the probability topic itself. And at this point we're looking at the example, and this example is on page. Example on page 397. Alright. So we are told that the additional law for probability. So we're looking at the examples for exercise 12.1 out of the Keeping Math Simple textbook. And it's on page 398. Okay. So mutually exclusive events are events that cannot take place at the same time. If two events A and B are mutually exclusive, then the additional law is the probability of A or B is equal to the probability of A plus the probability of B. And we spoke about that when we dealt with the example of the spinner further up. Okay, so now we're looking at example 1, which is on page 397. So here we are told that a bag contains 5 red discs. So you got 5 red discs, 3 blue, and 2 yellow discs. So how many discs are there in total in this bag? There are 10 discs in total. Not so. A disc is drawn at random from the bag. Okay? So that means to say it's equal likely to draw any of those discs. Also the discs are the same and you don't look at what you are drawing. Okay, some of you would prefer red over blue, whilst others yellow over red, whatever the issue is. Okay, so when it says you are drawing at random, then there's no preference and the discs are the same size. So if there's a disc that is bigger, of course, the chance of you drawing say for argument's sake, the 2 yellows are bigger, the chance of you drawing the yellow would be greater. Not so. So that's why they say at random from the bag. So whenever they say that, have that in mind. Calculate the probability that the disc is. So in the first case, that it is a red disc. So how many red are there? Remember how we calculate probability? Number of favorable outcomes over number of possible outcomes. Okay, so you can write in here P of R or P red or just P, doesn't matter. Okay? So how many red discs are there? There are 5 out of 10 discs, which is R. Okay, we always tend to simplify. And earlier on we also mentioned that the half could be represented as a half or 0,5 or 50%. All of these are acceptable. You're going to get full marks for it anyway. You don't have to write all 3. Any one of it will be suffice. Okay. Let's look at B. Question B says a blue disc. A blue disc. How many blue discs are there? There are 3. So the probability of blue is going to give you 3 out of 10, which is 30% or 0,3. Okay. You'll see me write it often as a fraction. Okay. Let's look at C. C says a red or blue disc. So are these events mutually exclusive or not? Yes, it is mutually exclusive. Why? Because you can't, if you're drawing one disc, you can't draw a red and a blue at the same time. You guys understand? So they are mutually exclusive. So the mutually exclusive formula was the probability of A or B is equal to the probability of A plus the probability of B. You all agree with that? This union is or the intersection is and. We did that last year as well. Okay. I think they either put or and now in these textbooks. Okay. But if you see that, I might write it like that. So remember it's or, otherwise when the n is the other way over the sign is the other way around, is the and. Okay, basically where it intersect. So what's the probability of A? So in this case, we're going to look at, so if we apply this definition or this identity or formula, it will be the probability of, they ask for red, the probability of red or blue is equal to the probability of red plus the probability of blue. Okay. You don't need to rewrite it? No, you didn't need to rewrite it. Okay. Just showing you in terms of what we have here. So what's the probability of red? Of, and the probability of blue? 3/10. Not so. So that's going to give you 8 over 10, which is 4 over 5. Okay. Is there any confusion? Okay, this is fairly simple. Still dealing with grade 10. Okay. Let me know when I'm moving too fast. Okay. So let's look at events that are not mutually exclusive. We're still reading from page 339. Events that are not mutually exclusive can take place at the same time. In such cases, the more general rule for addition of probabilities is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so later on when you probably see me write this, I would probably write it as probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay, so if you see that formula, now it is the same. Okay. See any confusion this one? No. Okay. So let's look at example 2. Example 2 is on page 398. Okay. Page 398. A card is drawn from a normal pack of playing cards. Now you all know what playing cards are, no? Alright. A playing card has the following suits. They call it suits. Now what suits we have? Spades, okay. I thought you were going to start with hearts since we had the girls' school. But we have spades. Now in a spade suit we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Not so. Now, some of you would say, but why are we putting the ace first? No? The ace is supposed to be last. Because in some games it's your highest card. Sometimes it's the lowest card. Okay? So in an exam, they must tell you where the ace belongs. The ace belongs to the set of picture cards, or the ace is at the back of the king, or the ace is in front of the two, if it even affects the question they ask. If they don't specify, then you in the exam can treat it either or. Okay? Don't call me and ask this and that. You treat it anyway. Okay? And when we mark, we have to give you the mark. Because there was a fault from our side. Okay? We didn't specify. But majority of the time, even to fix the outcome or the calculation, we tell you where the ace belongs. Okay? If the ace is part of the picture cards or not, or whatever. Okay? So, give me another suit. Clovers. What's clovers? Clubs. No? I call it clubs, you call it clovers. You're probably right. So, you'll probably do it better than me as well. But we'll get the ace of clubs. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king. And all of them are clubs. Not so. And this is called the black suits. No? The black suit. Okay. Then of course, we have the red suits. Still not odds. Yo, the diamonds. Okay. So you got the ace of diamonds, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay. And then of course, the Alright, again it's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, and this is your red suits. Okay. So, if we look at each suit, there's 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13. There are 13 cards per suit. So how many black cards are there? 26. And how many cards are there in total? 52 cards. Now when you open a fresh pack of cards, you get 2 jokers. Yes, there's people saying jokers. We get the guarantee card. Okay, if there's something wrong with the pack of cards, then bicycle has a card in there, that's your guarantee card. You must send it with the spades card and your complaint, your ace of spades, and you send it with your complaint and whatever card is the issue, you can send it with. Okay? Then you also get your blank card in the set. There's a blank card and there's a poker rule card. So there's 5 extra cards in every fresh pack of cards, which means to say it hasn't been opened yet. You're opening it up for the first time. There's 5 extra plain cards there. Not necessarily plain cards, but there's 5 extra cards in the pack. Not so. But when they're talking about a normal pack of plain cards, they're not including those 5, any of those 5 cards. Especially the jokers that some of you want to have in here. No? That's what we live for. No? For the jokes in our lives. But no, the jokers and those guarantee cards and all of those are not part of the set when they're speaking about a deck of playing cards. Okay, you guys understand? Right. So again, a card is drawn from a normal pack of playing cards. Calculate the probability a card is drawn at random will be. So again, it says drawing at random, which means to say it's equally likely to draw any of those 52 cards. Okay, the aces doesn't have preferences to the queens or whatever. It is equal likely. Okay, so let's go. The first question. A king. People, how many kings are here? You have 4 kings. Not so. They didn't specify king of hearts, king of diamonds. So a king. So the probability of drawing a king, of course, is going to be 4 out of 52, which is 1 out of 30. Let's look at B. A heart. Okay. Just watching. In case it's not recording. Right, people? A heart. How many hearts are here? There are 13 hearts. Okay. So it's 13 out of 52, which is 1 out of 4. You all understand? Let's look at C. A king and a heart. So what does that mean? The probability of a king and a heart. What do you think that would be? So how many kings are here? 4 kings. How many kings of hearts are here? 1. Can you see it says and? So it has to happen at the same time. It's the intersection of the two. Okay, you guys understand? There has to be a king and it must be a heart. So king of hearts is 1 out of 52. Okay. And then D, the question says, oops. And D says the probability of a king or hearts. So this would use the are all these mutually exclusive? No. Why? Because something can be a heart and can be a king. So if you count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in other words, there's going to be 16 here. But if we do this calculation, how many kings are there? 4 out of 52 plus how many hearts are there? 13 out of 52, which gives me 17, but we counted 16. Can you see that? But what happens, people? this king of hearts is counted twice. And that is the reason why we have to take that away, which is 1 out of 52. So 14 plus 13 is 17, minus 1 is 16 over 52. And 16 over 52 is 16 over 52, 4 over 30. Okay. Or we could have used the formula. The formula would have been simply the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersection B. In this case, we have kings and hearts. Kings and hearts. Kings and hearts. Okay. Which in turn gives us the probability of kings, 4 out of 52. The probability of hearts, 13 out of 52, minus the intersection of the two, which we calculated, was 1 out of 52. It gives me an answer, 4 over 30. Okay. People say any confusion. Okay, I can't help it, it's so easy, no? Right. So with that, you should be able to do exercise 1.2. 12.1, sorry. Because I'm going to stop it at the same. So this is the first lesson now, like this.